So as a refresher, for solving linear systems algebraically, we had two methods. Well, first of all, what is a linear system? Do we even know what that is? And that's fine if we don't. But a linear system is when you have like two lines drawn on the same graph, or you're thinking about two lines at the same time, and sort of where they cross is usually what we're looking for, or where one is bigger or where the other is bigger, or something along those lines. Okay? This is a very, very common problem that you see in the world. Most people solve it anecdotally, and by that I mean they kind of just think about it and go, yeah, this is probably the best way to do it. Things like, if you're going on a long trip, do you take the highway that is sort of a faster top speed but might have more traffic, so you might hit a traffic jam, or do you take a country road where you can't drive as fast and there's stop signs but there won't be traffic? Something as simple as that. It's not quite a linear system because you're not just driving one speed for the whole time, but it's kind of similar. Or something like maybe you take country roads, but it's a little bit of a longer because you have to go around. Like maybe the highway is more direct, or maybe the highway is less direct. I don't know. Okay, and you think about that, compare it to average speed. Which route are you going to take? People make these choices all the time. Should I walk this way to school or that way to school? Should I get up early and take the bus, or should I walk? It'll take me longer to have to walk, but I don't have to get up as early. All these questions are things we answer all the time, decisions that we make. And it's really very similar to like a linear system. So we don't use formal math to do it, but you do it all the time. So in this course, we did solve linear systems formally. We did it a little bit by graphing. You graph the two of them, and you just see where they cross. Okay, but we also did it algebraically. So let's look back and see what that looks like. So this was day 2, solving linear systems with substitute. Just watch, don't try to copy this down, but you do want to watch carefully. Okay. So how does this one work? I've got two equations. So in this example, we took equation 1. There it is. We moved 3x to the other side and solved it for y. So it says y equals. Is this familiar at all? I hope it's at least kind of familiar to most people. Okay, and then look, this is the really important step. This is the substitution. It says y equals this, negative 3x plus 10. So I took that and subbed it into y in the other equation. Look, negative 2x plus 3y, there's my y, equals negative 3, equals negative 3. So I subbed it into the other equation. I put brackets, a big set of brackets, and I took y and I subbed it in. And then you have an equation that just has x in it, and you expand the brackets, isolate x, move the 30 over, and divide by 11, and we ended up with x equals 3. You take that 3, you sub it in, and you find y, and then you've got your answer. Long step. Okay, lots of algebra. You got to do the steps in the right order. You got to watch your signs, like all these little details, but we did practice it over the course of a week or so. It was a while ago. That's one of the methods, substitution. What's the other method? It's called elimination. So what's different about this one is you notice that I've got my variables have the same coefficient. This is 1y and 1y. They had opposite signs. So we added, do you remember doing this? 1 plus 2. So y plus negative y is 0. X plus x is 2x. Negative 6 plus 4 is negative 2. And then I just solve for x. And then I do the rest of the question is the same. I take that, shove it into one of the equations, and find y. Here's another one. What's a better example maybe? Here's one. So again, 2 and 2. That one will work. 3 and 5, that won't work. You add them, you get 8. You subtract them, you get 2. Doesn't matter what you do, it won't work. In this case, we're going to add because they have opposite signs. That's going to make it 0. In this case, we subtracted, right? 1 minus 2, so x minus x was 0. So you got to be a little bit careful of that stuff. Starting to come back a little bit. Okay, so substitution, you have to be able to isolate x or y. Elimination, you have to get the coefficients the same. We're going to practice this over a couple of days, so you don't have to know exactly how to do it yet. Let's make our note. For substitution, you have to solve for x or y in one of the equations. Then sub into the other equation. So here's an example. X equals 3y plus 2. Or y equals negative x minus 4. Whatever it works out to. One or the other. Something like that. If you end up with a fraction, I don't know if you remember this, but if you ended up with a fraction, you probably chose the wrong thing. You should have done elimination. Or you should, we're trying to avoid fractions. Okay, when we're doing substitution. So for elimination, we're trying to get the coefficients. So we need to get 2 coefficients the same. Then we add or subtract depending on the sign. Is it positive or negative? So for example, one example would be something like 2x plus y equals 5, 2x plus 3y equals 1. Check. That's good because the x coefficients are the same. Yep. Right. So that's if they're not already the same coefficients, we can make them the same. Yeah. So we'll see an example of that. Sorry. But eventually you have to be able to make it so both equations, equation 1 and equation 2, have the same coefficient. That's our goal for elimination. People have favorites. Some people like substitution better. Some people like elimination better. Depends on the kind of question that you get. Depends on how it's set up. Elimination will always work. Substitution, sometimes you end up with fractions. So, I mean, if you were good with fractions, then you could also always do eliminate or substitution for sure. Okay, so that one's going to work because the 2x's, it's 2x and 2x, or 2x and negative 2x, like sign doesn't matter. Okay, we're going to do examples of all these, don't worry. What if I had x plus 2y equals 6 and 3x minus 4y equals 7? That one will not eliminate. So yeah, you can set it up to still use elimination, but at this step, it's not ready to eliminate. That's all I mean by that. That's just we're trying to visualize the goal of elimination, how it works, what we're looking for, what we're trying to get. Any questions on that? So we're gonna take today and tomorrow to review the whole skill of both. So there's gonna be time to practice both types, but we're adding a little bit to it as well. Is everybody okay? Everybody got that down? But we're going to add a little bit to it where you have to, and I think this will help us review and get back in shape with this stuff. We're going to also learn how to tell if it's better to use substitution or better to use elimination. This is a little bit of an individual thing because, like I said, you could kind of use either of them for any type of equation. And some people might just say, you know what, I like elimination, I want to use it better. But there's still once in a while where substitution is going to be way less work than elimination. And in some ways, it would be the better choice. Okay. So, but for most applications, you could use either. If you were given a test, it's not about you have to do this one. But it is about understanding and thinking about the algebra and analyzing and that kind of thing. Okay, so you don't have to write this down. You could just watch, but please, you want to participate. How do we start this? We've got equation 1 and equation 2. And it doesn't tell us if we're supposed to solve by substitution or solve by elimination. So I have to come up with a plan. I have to understand both processes. And I have to think, well, this one works this way. That one works that way. Which one is going to be easiest, simplest, straightforward for this question, for this system, and why? How many people, if you had to guess, I won't pick on you, put your hand up if you have a gut feeling about which one you would do, substitution or elimination. Okay, good. Ethan, what do you think?
Elimination, because the equations are illustrated.
Because the equation, well, wait, which one do we isolate? Or what do you mean by isolation?
Sorry, I didn't say isolation, but elimination, the
Coefficients, yeah.
yeah, the coefficients are already
Okay, which coefficients? Those coefficients aren't the same, right? Because it's 1x and 2x. But the y's are, it's 1y and 1y. So that would work for elimination. Kenzie, what do you think?
I would do substitution.
Why?
I don't really know how to explain it, but like I would be able to sub the negative 2x plus 15 into the y in the first equation.
Okay, good. But see how what I mean? Like everybody's different. People are going to see these different ways. That's not about right or wrong. So what Mackenzie's saying is this one is kind of already set up for substitution because it says y equals. When Ethan said isolated, you were right. This one is isolated for y. So I could take negative 2x plus 15 and replace y with that expression. That's what substitution means. That's what substitution is. So it's already set up for that. That being said, in one step, if I move the 2, I have to move the 2x over, because we haven't talked about this right, we haven't reviewed everything for these processes, but for elimination, I've got to have x's, y's equals numbers, like they got to be in the same order. But in one step, it would be ready to eliminate. And you're going to find that's true for a lot of these questions, is you can somewhat easily do both, okay? But that's what we're looking for, is how do I want it set up for substitution? How do I want to set it up for elimination? Okay, so let's say we could use substitution because equation 2 is solved for y. Again, you don't have to write this down. It'll be online if you want to look at it there, but if you want to write it down, that's fine. That's great. We're gonna actually do a couple of examples in a minute to review them, and that's what you want to definitely have written down. Okay, what about this one? What does it look like? Would you use substitution or elimination? Brianna? How come? Coefficients, very good. So when you say aligned, What Brianna means is the x's are together, the y's are together, like on top of each other. The equal sign is on top of each other. That matters too. And the numbers, the constants, are aligned on top of each other. Really important for elimination. That has to be set up that way. If it wasn't set up, you'd have to do it you'd have to put it in that form, or it wouldn't work. So this one looks like it's set up for elimination because it's in the proper form. And the x's have the same coefficients and the y's have the same coefficients. Okay, good. Let's take a look at C. I'd say it got a lot harder quickly. Without having done an example in a while, we haven't actually gone through a whole example, it might be tricky to visualize, like, well, what's the first step? What does it actually look like? But that's what you want to do. Like, what would be my first step? If I pick substitution, what would I do in order to substitute? If I picked elimination, what would I do as my first step in order to eliminate? If I go back up, remember, it's important for substitution that it says y equals or x equals a thing. And if I pick elimination, I have to have my coefficients lined up and the same. This one doesn't quite match either of those things. Noah, what do you think? Why? Very nice. I could multiply the first one by 2, 6x, 4y, and 4. I have to multiply everything by 2. And then I got 4y and 4y. It would work. What else could I do, though? Y, I think, would be tricky, but I could isolate x by moving the 4y over, and then it would say x equals, and I could do substitution in one step. It'd be ready to substitute. In one step, it'd be ready to eliminate. What else could I do? Anybody see? There's one other option. There's not like a different, there's only 2 methods, but I could multiply equation 1 by 2, or I could by, if I multiplied equation 2 by 3, I'd have 3x and 3x, so I'd have the x's the same. So in one step, I'd be set up to eliminate x's, or one step set up to eliminate the y's, or one step set up to isolate and substitute. So this one's either. So just watch. Okay, put your pencil down and watch, because I'm gonna go through it, but I'm gonna erase it. So you're not gonna be able to write this down anyway. If this was equation 1 and this was equation 2, if I picked substitution, I'd do this. From 2, I'm just gonna write it down, plus 4y equals 10. I'd go minus 4y, so these have opposite signs, and it's going to be 0. And then subtract 4y on the other side, and I'd get x equals 10 minus 4y. And bam, I can substitute that in for x in the other equation. So that's one thing that I could do. If I did elimination, I could do equation 1 times 2. So that would give me 6x plus 4y equals 4. I'd call that equation 3. And then I would subtract those two to get rid of the y's. They have the same sign, so I would subtract. Right? So in this case, I would say you could do either. And it's one step to get there. Okay, let's try D. So I want everybody to try to come up with what they would do. Now that we've gone through a few examples, which one? And if you're thinking to yourself, I have no idea and I don't know how to figure that out, fine. At least you know where you're stuck. And you know the question you have to answer for yourself before you move on today. And I'll help you with that. So put your hand up when we start practicing, and we'll talk about it, and I'll answer your question. We'll see if we can get you going. But if you're like, I have no idea. Substitution, elimination, I have no idea. That's fine. But you got to make sure you know that that's your answer. No matter what you do, you can't figure it out. But try to think about the two options, isolate or coefficients. Which one would you do in this case? Again, it's not about right or wrong. It will be true that in some situations, only in some, one of the two will have fewer steps, and one will be more steps. But if you end up with the right answer, it won't matter. So here's what I want you to do. We're going to do just a really quick vote, okay? And remember, there's no right, wrong answer. It's just like the last one, right? Either. I'm curious, so I'm going to ask how many people want substitution, how many people want elimination. Everybody has to vote. So pick yours. No, you pick one or the other. So pick one. You got 5 seconds. How many people pick substitution? How many people would pick elimination? Almost everybody voted. So I'd say more people picked elimination, but okay, so substitution, what would you do? Anybody want to answer that? Right, so in equation 1, I could take 2y, move it to the other side, and it would say x equals, and I could substitute. What would you do for elimination? Very nice. Multiply the first one by 3 so the x's match, and then you could eliminate x. Can you eliminate y? Not in one step. This is why you need to kind of practice and be able to think a bit open-mindedly about this stuff. Some people get like, they always want to do it the exact same way, so they're always going to try to eliminate y. And in this case, that would be more work. Because you'd have to multiply this by 5 and that by 2, turn them both into 10. But it's more work. So that's what we're aiming for. In this case, I would say either. Okay, let's actually do one start to finish. Let's see how we do. We are going to do both of them the same way as a class so that we have tried one of each type before we move on to the practice. So keep that in mind. Like you may have a favorite that you're always going to try to use eventually, and that's okay. If you get really good at it and you can always do that, then that's fine. But we're going to practice each type at least once here. So and I think you want to copy this down. You're going to do some of this work. Remember, we always start by so what's going to be our best method for this one? What does it look like it's set up to use? What would be your guess? Summer, what do you think? Why? Okay, good. So we're going to use substitution. And here's our, substitute. Here's our review of the substitution method. Some of the questions might be a bit harder because you might have to isolate. So if you get stuck on that step, put your hand up and let me know and we'll work through it together. So what am I going to substitute? I'm going to go equation 2 into equation 1 because this one's already isolated. And if you want to watch what that looks like, it looks like this. X plus y equals -6. But what is my y? It's that. So -2x plus 15. I'm going to help with one more step, then I'm going to see if you can do the rest. I put these brackets just to illustrate the substitution. We didn't really necessarily need them there, but this is like a positive 1 times both of those things, right? So if I do, this is going to be x minus 2x plus 15 equals negative 6. Now you want to solve that for x. See if you can solve that for x. Go ahead. Somebody tell me what x minus 2x is? Negative x, good. Negative 1x plus 15 equals negative 6. What do I do next? Move the 15 over. Nice. And how am I going to do that? So remember the trick here, we've done a lot of this year, but the trick here is these two things have to have different signs. So the 15 in the equation is positive, so the one I'm adding to it is negative. So 15 minus 15 is 0, and I end up with negative x equals negative 6 minus 15 is negative 21. What do I do next? Divide by negative 1. Divide by negative 1. Divide by negative 1. Just flips the sign so x equals positive 21. Are we done? We're not done. Always remember what the purpose of solving a linear system is, to find the point where the two lines cross. So we're going to call this equation 3, and then we're going to go 3 into, let's put 3 into 2, because that'll just solve for y really easily. Into 2. So that's going to look like y equals negative 2 times x plus 15, where x is 21, right? I just subbed that in again. So that's negative 42 plus 15. And that's negative 27. So our point of intersection is x, y. X is 21, y is negative 27. If you graphed those two lines, that point would be way off the graph. We usually only graph up to like 10. And those lines wouldn't necessarily be nice to graph. But it's possible. You could graph it with technology easily. That's the point. X is 21, y is negative 27, where those two lines would cross. Any questions? Whoops, there's the other example. There we go. Let's try this one. Liam, you told us before what we would use for this one. What method? Do you remember what it was? Multiply the top one by? Very nice. So we're going to use elimination for this one. This is our elimination example. You could also isolate for x and use substitution if you prefer. But we're going to use this as our example of elimination. So, and this is one of the harder ones. It's equation 1 times 3. So I multiply everything in equation 1 by 3. 3 times x is 3x. 3 times negative 2 is negative 6y. 3 times 3 is 9. Remember, people forget to multiply the rest of it, or people forget to multiply the constant on the other side of the equals. All kinds of little mistakes that we make there. Call that equation 3. And how am I going to eliminate? This one's a trickier one. So I'm gonna yeah, Summer, what do you think? So we're going to do equation 3 minus equation 2. Or equation 2 minus equation 3. Doesn't matter. But you have to pick one and you have to do it the same. So watch. This is 3 minus 3, which is 0. This is 0. That's what we wanted. Gone. Here's the tricky part. What's negative 6 minus negative 5? Oh my gosh, use your calculator. This is something that people always have a hard time with. Is it 11? Is it negative 11? Is it 1? Is it negative 1? Like, what is it? Why? It's negative 6. Okay, hold on. It should look like this. Put your pencil down and watch. Negative 6 minus negative 5. You're subtracting, and it's already negative, which is negative 6 plus 5. So it's negative 1, right? So negative minus y. That's a hard one. Use your calculator. And then 9 minus 2 is 7. If negative y is 7, y is negative 7. Divide both sides by negative 1. Call that equation 4. We're not done yet. 4 into one of the original equations. I'm going to go into 1 this time. And that looks like x minus 2y equals 3. But what is y? It's negative 7. And then just solve. So x plus 14 equals 3. Subtract 14, subtract 14. X equals negative 11. Any questions? Tricky stuff.